So fuzzy logic provides a way. Cow! In this video, we will use Neuro Fuzzy Hybrid System to predict water temperature for water heater control system. Next, topics covered in this video. First, we will understand the two key components used in this hybrid system, that is neural network and fuzzy logic. Next, what is Neuro Fuzzy Hybrid System? Then we will try to understand this hybrid system using numerical example. Soon, in upcoming video, we will implement this hybrid system in Python. As you can see here, Neuro Fuzzy Hybrid System, it is also known as Neuro Fuzzy System or Fuzzy Neural Network. In Neuro Fuzzy Hybrid System, the principles of neural network and fuzzy logic are combined to develop a flexible and reliable system that can solve complex problems in the field of artificial intelligence, machine learning, and in control systems. So we can use this hybrid system to solve complex problems in machine learning, artificial intelligence that alone neural network or fuzzy logic cannot solve. So in this hybrid system, the strength of both neural network and fuzzy logic is combined together to develop a powerful system to solve complex problems. So in Neuro Fuzzy Hybrid System, a hybrid approach is used that take the advantages of the strength of both neural network and fuzzy logic to handle non-linear and complex patterns efficiently. So in this hybrid system, a hybrid approach is used that is taking the advantages of both neural network and fuzzy logic. So we will combine their strength together and form a hybrid system. So as you can see here, two key components are used in this hybrid system: neural networks and fuzzy logic. And here you can see the working of Neuro Fuzzy Hybrid System. So in order to understand this working numerical example, first you will understand the two key components, what is neural network, fuzzy logic, and further they have different key components. So first you will understand these two key components so that we can easily understand the working of Neuro Fuzzy Hybrid System. So first we have neural network. Neural network is inspired by the structure and the functioning of human brain. Neural network is a method in artificial intelligence that is used to train data in a simple way like humans do. We can use neural networks to perform different tasks like pattern recognition, image recognition, classification, speech recognition, and many more. Now we will discuss the key components of the neural network. Here we have neurons, that is also known as node. So here we have artificial neurons, that is also known as node or perceptrons. Artificial neurons are inspired by the biological neurons and used to perform computational tasks. Here artificial neurons can take one or more input and weighted sum of inputs is performed. Then activation function is applied and the output is produced. Weights W1, W2, W3 up to Wn. Weights are used to determine the strength between neurons, and each connection between neurons has associated weights. During neural network training, the weights are adjusted to optimize performance for specific tasks. Next we have activation function. Activation function allow neural network to learn complex patterns. Each neuron apply activation function to its weighted sum of inputs. Next we have different layers used in neural network. Neural networks are organized into layers. Here we have three main layers: input layer, hidden layer, and output layer. Input layer receive input and data and proceed it to the next layer, that is hidden layer. Hidden layer is between input layer and output layer. This hidden layer is responsible for learning features and representation in data, and neural network can have one or more hidden layers, depends on the task. Last layer we have output layer, that is used to produce output, and number of neurons in the output layer depends on the task. For example, for binary classification there is only one neuron in the output layer, and for multi-class classification we have multiple neurons in the output layer used to produce output. Like that, we have different components in the neural network, like cost function, that is used to measure errors, backpropagation, feed-forward propagation, training data, hyperparameters, and deep learning. Next we have fuzzy logic, that is a computational framework used to deal with uncertainty and imprecision in data and decision making. Fuzzy logic is also inspired how humans make decisions when confronted with unclear or confusing information. For example, you can see here this glass of water. Here we have two cases. Either we can say it is half filled with water or it is half empty. Now, how machine will make decision? Now we will use the fuzzy logic here. Suppose range from 0 to 1. So a machine can say the water level is at suppose 0.5. According to fuzzy logic, water level is at 0.6. So fuzzy logic provides a way to represent and manipulate unclear information and making it suitable for the application, where the traditional logic, that is crisp logic, is insufficient. Now next, what is crisp logic? So crisp logic is traditional binary logic that categorize statements as either true or false. For true value we have 1, for false value that is used 0. So for each statement it will answer as true or false. For example, if it is raining, if this statement is true, then take an umbrella, else if it is not raining, then do not take an umbrella. Now suppose right now it's not raining, but outside it is cloudy and after an hour it can rain. So in this case the crisp logic fails, as according to crisp logic, if it is raining then take an umbrella, else do not take an umbrella. So here we have no solution. So here we have no solution for the uncertainty. So the crisp logic, that is the traditional logic. So the traditional logic cannot predict the uncertainty. That's why fuzzy logic is often considered better than crisp logic, because in the traditional logic the decisions are made only on the exact conditions. True or false, there is no prediction in between true and false. So in crisp logic there is no room for the partial truth. We can use crisp logic, but we can use crisp logic in computer programming. A simple example, suppose we have two numbers 6 and 5. Condition is if 6 is greater than 5, then display 6 is greater. Here we can use the crisp logic as we have the exact condition and it can give the accurate result. In short, we can say the crisp logic is well suited where the information is clear and unambiguous. That's why fuzzy logic is considered better, as it can make decision based on partial truth, human-like reasoning. Now we have different components used in fuzzy logic that are further used in this Neuro Fuzzy Hybrid System example. So one by one now we will understand the fuzzy logic components. First we have linguistic variables. Linguistic variables are used to describe the imprecise data in natural language. For example, you can see here we have variables temperature, speed, and size. Here we have the variables. Next we have the values for the variables. For temperature we have value warm, cold. For speed, fast, slow. For size, large, small, medium. Next we have membership functions. Each linguistic variable is associated with one or more membership functions. For example, you can see we have variable temperature, and its value warm. Membership functions are represented as curves or fuzzy sets that assign values between 0 and 1. Here you can see the membership values in between 0 and 1. These values indicate the degree to which an element belongs to a particular set. Next we have fuzzy set that represent the extent to which an element belongs to a set. Each element has membership function between 0 and 1 that indicate the degree of membership. Next we have fuzzy rules. Fuzzy rules are used to define the relationship between input linguistic variables and output linguistic variables. And natural language is used to express each rule in form of if-then statements. Here you can see, for example, you can see here we have different rules. Fuzzy rules capture exact knowledge and used to make decisions based on the fuzzy input data. When the room, for example, if room temperature is cold, then heater power is high, because when there is cold temperature, we want to increase the heater power to warm it up. Next rule, if the temperature is normal, then heater power is medium. Third rule, if the temperature is warm, then heater power is low. Next we have fuzzy inference, the process of applying fuzzy rules to make decisions or draw conclusion based on fuzzy input data. Defuzzification, when the fuzzy inference is applied, the output need to be transformed into crisp values, that is numerical values for decision making. So fuzzy logic is used in traffic control, temperature control, customer electronics, medical diagnosis. Now we have Neuro Fuzzy Hybrid System. In Neuro Fuzzy Hybrid System, we have different components like fuzzification, rule-based fuzzy inference, defuzzification, and neural network integration. In the fuzzification, the crisp input is converted into the fuzzy sets. For example, we have linguistic variable, temperature, and for this variable we have 3 different values: cold, normal, and warm. Now for this we have membership function. Now you can see for each value we have membership function. For cold, you can see from 0 to 40, for normal temperature 35 to 75, for warm it is 60 to 100. Now suppose we have the crisp input, it means we have the input value for the room temperature, it is 68. After that we will calculate the membership grades. So here the fuzzification process started. Now we will understand the working of Neuro Fuzzy Hybrid System using a numerical example. So here we have 4 different components for Neuro Fuzzy Hybrid System. First we have the fuzzification process, then we will apply rule-based fuzzy inference, then defuzzification, and after that here we will integrate the neural network. So first we have the fuzzification process, where the degree of membership is calculated for each linguistic variable to check it belongs to which category, that we will perform step by step in the numerical example. Next we have rule-based fuzzy inference. Here fuzzy rule describe the relationship between input and output in linguistic terms, and they apply to fuzzy inputs to produce fuzzy output. We have defuzzification, fuzzy output converted back into the crisp value. The last one we have the neural network integration. The crisp output from the fuzzy system can be used as input to the neural network. A neural network can further refine the output. Now we will use Neuro Fuzzy Hybrid System to predict water temperature for water heater control system. Here first step we have fuzzification. So first we will define the linguistic variables for water flow rate. So here we have water flow rate and heating temperature. So in step 1 we will define the linguistic variables and membership functions for their input and output. So first we have the linguistic variables for the water flow rate, that is it can be the low, medium or high. Then we have the membership function, and you can see for the low, then we have medium, high. So it is just considered, for example. Next we have the linguistic variables for the heating time. So heating time can be short, medium or long. Next we have the membership function for the short, medium and the long. So we have the range here. The last one, we have the linguistic variable for the water temperature. Water temperature can be cold, warm or hot. So here we have the membership function for cold, water, cold, warm and hot. Now in the next step we have the rule-based fuzzy inference. Now we will define the fuzzy rules to describe the relationship between inputs and outputs. So here we have different fuzzy rules. If the water flow rate is low and the heating is short, then we will consider the water temperature hot. If water flow rate is medium and heating is also medium, then the water temperature is warm. Third rule, if water flow rate is high and heating temperature is long, then the water temperature is cold. You can see if water flow rate low, heating time short, temperature hot. Then for medium, if water flow rate is medium, heating time is also medium, then temperature is warm. The last one, temperature is cold when the heating time is long and the water flow rate is high. Now we have defuzzification process. So we consider two values for water flow rate and the heating temperature. Suppose water flow rate is 75 and the heating temperature is 25. Here you can see it is medium and short. As you can see, for it is considered, heating temperature is considered 25, it is medium. Now we will use fuzzy inference engine to calculate degree of membership for each. First we will perform for water flow rate. Here we have low, medium and high. For each we will calculate degree of membership. Here you can see the formula. We have degree of membership x minus a divided by b minus a. So here x is the input value. So we have input value x for the water flow rate 75. X is 75. A, that is the left value. B, that is the right value. So for low you can see here. So one example, for low you can see the value we have 0, 20 and 40. 0 is the left value and 40 is the right value. Or you can say this is the lower bound and the upper bound. So you can take, or second way we can consider this lower bound and this is the upper bound. So here we will put the value x minus lower bound, that is a, divided by upper bound minus lower bound, or you can say b minus a, right value, right point minus left point, anything you like, anything. So for low, so the degree of membership for low we have 1.87. Next we have degree of membership for medium. Again put the value of x, that is 75, then lower bound divided by upper bound minus lower bound, like that for the high. Now we will calculate degree of membership for the heating time. Again we will use this method, but this time the value for x we have 25. As we considered the value for heating temperature, it is 25. So we will put the value for x 25, lower bound, then upper bound minus lower bound. Now for long you can see, so when we are calculating the value of membership for long, you can see we got negative value. So we cannot consider negative value, so it is capped as 0. Now we will evaluate each rule. First we will consider the minimum value among water flow rate minimum. So first we have degree of membership for water flow rate medium and degree of membership heating rate for the short. As you can see, for the short we have value 1.25 and for medium it is 1.125. So among all, the shortest one we have 1.25. Next rule, for the next rule, the minimum value we have for the heating time medium, and for third rule we have the minimum value, and for third rule we have the minimum value for heating time long, that is 0. Now using weighted values, we will find out the centroid of the combined output membership function for the water temperature. For water temperature, we have three values: cold, warm and hot, and you can see the membership we calculated, and you can see the degree of membership calculated for each value. For cold 0.0, warm 0.25, hot 0.75. So now we calculate the area of cold. Base into height divided by 2. Base value we have 20, height we have 1 divided by 2. Here you can see. Next, for warm and hot, calculated the area. Now we will calculate the centroid here. Centroid. For the centroid, we will use this equation: area of hot into centroid of hot plus area of warm into centroid of warm, area of cold divided into centroid of cold divided by area of hot, warm and cold. So put all the values here and we got the value, that is 50. So this 50 is the defuzzified output of the water temperature. So here you can see membership function we have. For warm, you can see this value we have 50 here, so it is warm. Now we will use this value 50 in the neural network integration. So the last step we have neural network integration. So we will use here simple feed forward neural network which have one hidden layer. So we will try to do this with numerical example. So no training is done here. We will consider the values and we will try to do it numerically. Here you can see the neural network architecture. In the input layer we have one neuron, in the hidden layer we have two neurons, in the output layer we have one neuron. Then suppose we train the neural network, and after the training, suppose we got the values here for input to the hidden layer weight. For the first neuron, weight suppose 0.6, for second neuron, and then in the hidden layer in the biases, suppose we got the values after training. Now we will calculate the output of the neural network and we will use the weights, biases and the water temperature 50 that we calculated before, that we calculated here. The fuzzification output of the water temperature 50. So now this process started here. Now we will calculate output using neural network. First we will calculate the hidden layer input. So here you can see for first neuron formula we have water temperature into weight plus biases. Put the value, calculate the input. Then for the second neuron, then for the neuron in the hidden layer, then for neuron 2, then we will apply the activation function to the hidden layer neuron. Here apply the activation function for, so we have two neurons in the hidden layer, so apply here the activation function on the neuron. Hope you can see all the calculation here. Last we will calculate the output layer input, that is before the activation function. So here neuron 1 output layer, you can see the output of the neuron 1 in the hidden layer into its weight plus bias. So enter the values here. Last we will apply the activation function to output layer neuron. So here one neuron is in the output layer that is used to produce the final output. So put the value here and we got the output value, that is 0.764. that is, it represents the water temperature is between warm and hot. So the final value we got here is 0.764, and you can see the degree of membership we have 0.764. So it is between warm and hot. So temperature is considered between warm and hot. So this is not the exact value, it is the predicted value, plus we haven't performed any neural network training or we don't have any input data set. So all the values are just considered and the final output value we got here, it represents the water temperature is between warm and hot, as we got the value 50 here and it represents it is warm. And the final output we got, it also indicate, and the final output we got after neural network integration, it also indicate that the water temperature is between warm and hot. Done. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.